Water, molecular formula H2O, makes up most of the mass of living organisms, and it's an especially unique substance because it's polar. So let's talk about polarity. If we look at the structure of water in that bent formation, we want to consider the electrons that are surrounding it. So let's throw some electrons on there. Okay, so what we see is that oxygen is highly electronegative. It holds onto electrons more tightly than does hydrogen. So electrons spend more time around oxygen than they do around hydrogen. What this does is it makes this side of the molecule, the oxygen side, slightly negative, and the hydrogen side of the molecule slightly positive. And that is what polarity is. Atoms on both sides of these bonds are partially charged. Now it's important to remember that the molecule overall doesn't have a net charge. It's a neutral molecule, but there are regions that are slightly positive and slightly negative. So that polarity, we'll see, gives water all of its unique properties. The polarity leads to a special kind of bonding between water molecules called hydrogen bonding. So again, we see a few water molecules here with the positive regions around the hydrogens and the negative regions around the oxygens. And what will happen is, similar to an ionic bond, we'll have an electric attraction between those polar regions. And those are the hydrogen bonds there in the dashes. So you see the positive hydrogen interacting with the negative oxygen of another molecule. And each water molecule can form up to 4 of these hydrogen bonds. And of course this goes on, right? Where we have water interacting with all of the other water molecules through hydrogen bonds. Now this gives water all of its very unique properties. We're going to go through them now. First, water is an excellent solvent. It's able to dissolve many different kinds of substances. So let's picture a beaker of water, say, all these water molecules, where we add some sodium chloride to it. Remember, sodium chloride is made of 2 ions that are held together with an ionic bond. Now, all of those polar water molecules are going to overcome the strength of that ionic bond and break those 2 ions apart. You see here the negative ends of the water molecules around the oxygen are interacting with the positive sodium cation, and all the positive regions of the water molecules, the hydrogens, are interacting with the chloride ion. And thus we see salt dissolving in water because water is such a good solvent. Another important property of water, because of all of those hydrogen bonds, is its cohesive and adhesive properties. Cohesion is the ability of water molecules to cling to each other, while adhesion is their ability to cling to other surfaces that must also be polar. So if you think about water in a stream, or even the fact that most of your blood is water, that makes an excellent transport system because of its ability to cling to itself. So it can carry all of those small particles in the stream. It can carry your dissolved ions in your blood, as well as blood cells and so on. Also, the cohesive and adhesive properties are responsible for the movement of water through trees, which is a process that doesn't require any energy at all. The movement of water is like a column of water through a tree, where cohesion is holding those water molecules together, while adhesion helps them stick to the sides of the small vessels in the tree. Water also has very high surface tension, again as a result of its polarity and hydrogen bonding. Those water molecules at the surface of water cling more tightly to each other than they do to the molecules in the air, like oxygen and nitrogen. If you've ever seen a water strider on the surface of a pond or a lake or a small stream, you know that they fully utilize their ability to take advantage of this surface tension by skating around on the surface, hunting down small prey, and thus they have an entire habitat available to them as a result of the high surface tension of water. An especially unique property of water is its ability to expand when it freezes, thus making it less dense as ice than when it's liquid water. So if we look at some liquid water molecules here bouncing around each other in its fluid form, and then we start to turn the temperature down, and when we reach the freezing point, all of those molecules stop moving, and they will hydrogen bond with each other in such a way that forms this certain geometry that takes up more space than in its liquid form. So the same amount of water is taking up more space, which means that it's less dense. Now, since ice floats because it's less dense than liquid water, that means that only the surface layers of aquatic ecosystems like lakes and ponds will freeze during winter, and therefore prevent solid freezing throughout the water column, and that enables the survival of many biota like fish and insects. Also, because of that expansion that happens upon freezing, ice can cause the erosion of the landscape, like you see here in this picture of mountains slowly crumbling over time. Finally, water has a very high heat capacity. All of those hydrogen bonds in water can absorb a large amount of heat without actually changing the temperature by very much. Just think when you put a pot of water on the stove and you turn on the heat. That volume of water takes quite a while before it comes to a boil and turns to steam. Now, this property of water is responsible for the cooling effect of sweat. Perspiration that builds up on our skin can absorb a lot of our body heat before evaporating and cooling us off. Now, this works the other way as well. Since we are mostly water, since organisms are mostly water, then this absorptive property of water also allows us to resist temperature changes when temperatures get very cold. So water can hold on to heat very well.